Alfonso Langle. I'm a network scientist, and today we're going to talk about multi-level social ecological networks in a payment for ecosystem services in central Veracruz, Mexico. Well, we use social ecological networks to conceptualize the social ecological system. And in this case, we have forest units. And these forest patches can be connected if they are, we can say they are connected if they are separated by less than 1 kilometer. So in this case, this forest unit could be connected to this unit. So we can put a link. Also, we have, that's the ecological connectivity. Also, we have social connectivity, where these two households are connected if they have a information sharing relationship. And also we have a third type of link. It's a social ecological link. In that case, if this household do any type of conservation activity in this forest patch, we can consider that as a social ecological connection. Well, this came from the theoretical framework of the problem of fit. In that problem, we face different configurations in which these actors collaborate to manage together a source, a natural source. For example, in the scenario A, we have two actors who are not connected, and the forest patches are connected. So if those actors are, in this case, we can tell there is a misfit or a mismatch. And in the same case, in the scenario A, if the actors are connected and they coordinate their actions, they can manage these forests in a more efficient way. Well, in this case of a study, we are in Mexico, in the East Coast, in central Veracruz. Central Veracruz is covered by cloud forests, and these cloud forests are very important for water production. So in this case, this watershed produces 50% of the water that the Jalapa city needs. Jalapa city is the capital of Veracruz state. Veracruz is one of the most populated states in Mexico. In this program, the landowners get $85. $85 is an economic incentive to keep the forest. And well, this program, there is is a mix, because there is federal money from CONAFOR, from the National Forestry Commission, and it's also local funds from the water operator. And the research question that we analyze here is how to improve social ecological connectivity in the BISCAC PES, considering the spatial extension of the ecosystem service of water production. So first, we did a social ecological network survey. Then we map these social ecological interactions. We map these forest patches. Then we model the water production ecosystem service using INVEST. And finally, we did a principal component analysis. Well, at the social level, we collect a variety of social relationships like collaboration, information sharing, difficulty to collaborate. At the social ecological level, we explore 6 types of social ecological links, like conservation activities, property, neighborhood. And well, for example, and also, well, this is the type of relation. Now, well, interviews is like, in the last year, with whom did you collaborate in the program to take care of the forests that provide water to the city of Jalapa? In that way, we can collect collaboration links in the last 5 years of this PES program. So this is how we got the information about the forest units. So we ask the stakeholders. They make a draw of those units, which they have where they draw on the map the forest units with which you have some kind of social ecological relationship. So which of these do you have an ownership relationship with? Which of these do you have an usage relationship? In the main findings, we can say this PES program is an example of collaboration through spatial scales uh, of social structures and ecological processes. However, we found a spatial mismatch between social ecological connectivity and the ecosystem's process such as water production. Here you can see the social connectivity, and in this network, in this collaboration network, you can see how the NGOs are in central positions. That means they are in a position to be mediators between landowners and government officials. In this case, the water management office that provides the water operator that provides the water for the human consumption on Calapa City. We also can use this social ecological network analysis to assess the importance of each of these units. So in this case, the units with more connections, as the forest unit number 1, who is located in the upper parts of the watershed, like Cofre National Park, where the actors, they have more conservation links because it's a national park. And we can also assess the importance based on the water production modeling. So in this case, you can see the water yield of each of these, where the water yield is, and we can calculate how much water these ecological units produce. So as you can see, most of the water production is concentrated on the central area of the watershed, where the cloud forests are. The conservation activities variables explain 58% of the arrangement of the units. That's the axis number 1, PCA1. The water yield variable explains only 41%, that's axis PCA2. And both variables explain 99% of the arrangement of the units. Units number 1, 2, 8, and 11 are clustered according to their social importance, which means these are forest units where stakeholders concentrate their conservation activities, as in this case, the national park, Cofre National Park. In contrast, for example, units 12 and 9 are clustering according to their ecological importance, based on high water production, or high values of water yield. So we detect opportunities to increase the efficiency and effectiveness of the PES program. And conservation efforts should be directed towards the middle part and high part of the watershed, and increase trust and cooperation between landowners and government through intermediation of NGOs. So regarding public policy recommendations, we suggest that there be more information exchange between the NGO in brokerage positions and the water operator. Also, we suggest that we should strengthen links in the middle part to increase the fit of the system. So because what we found was a partial spatial mismatch, and that can, by directing the conservation efforts to the middle part of the watershed, that can be improve it, and the effectiveness of the payment can be improved. And also, we find that actors who have a central role in the friendship network, they can have an important play in conflict resolution. Thank you so much, and you are welcome to to read the paper and take a more deeper look in our findings. And this is, for example, this is the workshop in Jalapa City where we present our results to the stakeholders. Thank you.